Well, hey, and welcome to a little flip lesson about why we've learned so much about quadratics. How do we put all of our knowledge about parabolas and quadratics into the real world applications? So we started out, and please follow along in your guided notes and take really thorough notes. Don't just listen to the video, but write things down and pause the video and do problems as you're asked to do them. So we start out with a problem where we have a rabbit that's jumping over a fence, and it reaches this maximum height of three feet. And we know that from when it takes off to when it lands, it's 8 feet. And the first thing we're asked to do is to come up with an equation that models this parabolic path of this rabbit as it jumps through the air. So let's take a look at how we might do that. We have right now two different forms that we've learned that deal with quadratics and parabolas. One is vertex form, and vertex form is really handy when you know the vertex. This is our graphing form. And the other one is standard form. And standard form, it just kind of looks pretty, and it's all set up there for the quadratic formula. Well, in this case, with this particular type of problem, I thought it'd probably be best to use vertex form, because I think with a little bit of thought, we actually do know the vertex of this parabola. Let's come on down here and take a look at a graph of what's going on with this rabbit. If we put the rabbit's path here on the XY plane, and we start out from 0, 0, and the rabbit jumps in this parabolic path and it hits its peak or its vertex and it lands, I think we could figure out what this vertex here is. I mean, after all, what do we know number-wise? We know that this distance right here is 3, and we know that the total distance traveled from here to here is 8. So if you think about it, we know that the vertex lies right smack dab in the middle, and there's a considerable amount of symmetry to this parabola. So wouldn't that mean that we travel 4 units to get to that vertex on either side? So if we maybe draw a little picture and orient that picture right here on the coordinate plane, we might be able to start thinking about, we know this point right here is 0, 0. We know this point over here where the rabbit hits the ground would be 8, 0. And we know the vertex would be the point over 4 up 3. So when we come over here to fill in our values in vertex form, we know that the vertex is 4, 3. So remember, it's x minus 4. It's always the opposite inside. And out here we have a 3. But we do have a problem. And that problem is, what scalar do I have in front? What do I know about A? Well, chances are A is not 1. As a matter of fact, I think we all know that A would have to be negative, right, for this parabola to be a downward parabola. So how on earth are we supposed to find this scalar, this number out in front? Well, we actually can find that scalar pretty easily using this recipe we have over here. You see, this recipe gives us y values if we know x values. And when I look at the 2 points that this parabola travels through, I know that one of the y values is 0, while the other y value, or x value, is 0. Similarly, I could use this point, but gosh, zeros are so easy, I might as well stick with zeros. So if I come over here, I can put a 0 in for y, and that's from this 0 right here. I can put a corresponding 0 in from x, and that's this 0 right here. And I can find A using some basic algebra. Again, if we go all the way back to what an equation really is, an equation is just a recipe for finding all the x's and y's that make something true. So solving this equation, if I clean this up, and maybe I subtract 3 from both sides and divide both sides by 16, I get A equals negative 3/16. So right now, I'm able to find the equation of this rabbit's parabolic path, and it's y equals negative 3/16 times the quantity x minus 4 squared plus 3. And this takes us to this whole thing that I've kind of been giving you these sterilized parabolas to write equations of, where the value of your scalar is easily found by using our technique, our Barath graphing technique. But that's not always the case. You know, if we do our little reality check here, we don't live in this rainbow unicorn world where everything works out perfectly to fit our existing models. You know, sometimes those scalars, they're just not easy to see. And so let's take a little sidestep away from the word problems, and let's take a look and see if we can figure out how we'd write the equation of these two graphs right here, knowing the vertex and knowing 2 points through which they pass. So let's take a look at the one on the left. Since we know the vertex, we might as well use this vertex form right here. So I'm going to have you try this one on your own. So make sure you take really good detailed notes and pause the video and rewind the video if I go too quickly. Well, let's fill in what we know. I have this generic y, y equals here. Where is it? It's somewhere here. It's right here. Well, I guess first of all, we know the vertex is, where's the vertex? -3, 6. The vertex is at -3, 6. And that's going to give me the h and the k. But what I don't know is the a. But that's okay, because I happen to know 2 points that aren't the vertex that this parabola will pass through. So if I pick one of those 2 points, either -6, 0 or 0, 0, I'm going to pick 0, 0 because it's, 0 is such an easy number to work with. I can plug in this h, this k, this x, and this y, and I can find my a. So I'm going to do that right here. I'm going to go ahead and take this structure. I don't know what a is, but I do know that h is -3. Notice how the minus changed to a positive. And I know k is 6. And now I'm going to put that 0, 0 into the equation for x and y. And I'm going to solve this. And now it just boils down to a little bit of algebra. And we can find our value for a. And in this case, when we reduce this fraction, we get a is -2/3. And that gives us this equation. And notice I went back to a generic x and a generic y. Now, again, I was using a really nice point 0, 0 because the graph does go through 0, 0. I could have used -6, 0 and it still would have worked. But I want you to come over and try this problem on your own. This is the graph you have in your guided notes. I want you to identify this vertex right down here. And I want you to pick one of these 2 points and see if you can write the whole equation of the line. So pause the video, try it, and when you're done, check it out. Hey, welcome back. I hope that you found this answer right here. Y equals 5/2 times the quantity x minus 2 squared minus 7. If you didn't get that answer, please try it again. Check with your math friend and see if you both can come up with this, but this is the answer you should have. So having seen the rabbit problem, here's one that I'd like you to try on your own, and that's that we have a soccer ball being kicked. It's being kicked right off the ground. It travels 150 feet, and it reaches a maximum height up here of 100 feet. And see if you can come up with an equation that models this path. And again, if we orient this soccer kick, starting right here at the origin, starting right there at 0, 0, think about what happens when it hits the ground. What's the coordinate right here? And then think about when it hits its peak, right up here, when it hits its maximum value, where are we? We know the height is 100, but see if you can figure out that x. And now write that equation. Hopefully you have that equation written. Again, if you didn't get that, go back and try it again. I know the fraction's ugly, but you've got a calculator there to help you out. See if you can come up with that equation. Okay, so now I'm going to let you in on a huge secret about the vertex of a parabola. We have gone a long way, and we have gone through a painstaking method of finding this vertex. And I'm here to let you know that the vertex of a parabola is actually, it's been there all along. It's been lying in the quadratic formula. So I have here a graph, y equals x squared minus 2x minus 8. This is the graph of that function. And I went ahead and I marked where the vertex is. It's at 1, negative 9. And the whole key to finding the vertex, the quickest way, if your graph is in standard form, actually comes from the quadratic formula. And it turns out that the vertex can be found by just, let me see here, just this part of the quadratic formula. The x value of the vertex, is simply negative b divided by 2a. And if you think about that, if we go through and we kind of think about what's happening here, this right here is the axis of symmetry. I'm not really good at drawing with my mouse. This is the axis of symmetry of this parabola. And this axis of symmetry is the line x equals negative b divided by 2a. And when we use the quadratic formula, there's a whole second part. Ooh, I'm not really good at drawing with my mouse. This whole second part of the quadratic formula is responsible for moving to this root. That's the plus the square root of b squared minus 4ac all over 2a. And then moving over to this root. And that's the minus the square root of b squared minus 4ac all over 2a. But the vertex itself lies right smack dab right there on that x equals negative b over 2a. And so in this case, if you come up here and you look at this and you think about, well, how could we find the vertex super easily? All we have to do to find that vertex is simply put in, where's my pen here? Put in negative b. So in this case, that's negative 2 all over 2 times a. And in this case, a is up here, a is 1. So my x value of my vertex is simply 2 over 2 or 1. And sure enough, there it is. So knowing that, we can now go into this second batch of problems right here. In the second batch of problems, we have a cannonball being shot. We're given some information about its initial rate. We're given some information about how high above the ground it is. And we're given this formula that determines the height, h, as a function of time. So height depends on how much time has passed this way. You may notice that the 1.5 feet is the initial height. It's how high the cannonball was when it left the ground. This 48t deals with the upward velocity. And this negative 16t squared, well, that's nothing more than just gravity pulling that ball down. And we need to find out how high this ball can get. And to do that, I think we're going to have to go to part 2 of this video. So when you're all done, find part 2.